Hi everyone, my name is Jiadong. I'm going to give a presentation about our work, Messy State of Wearing, Vulnerabilities in Emerging Personal Payment Systems. This paper is co-authored with Professor Yuan from University of Louisiana and Lafayette and Professor Zhang from Washington University in St. Louis. The online payment services have become ubiquitous in our daily life. However, the barrier to entry is quite high for many small businesses. First, individual payment accounts on this platform are not designed to handle large volume of transactions. Second, in some regions, requires a government-issued license to get merchant account, which incurs considerable delay in applications. Lastly, there is also a non-trivial upfront cost commitment to getting started. Realizing these limitations, a new form of payment management services have emerged to serve as a broker between the buyer and the seller. We call this new paradigm the personal payment system. It couples the personal money transfer functions provided by existing third-party cash server with an order management platform developed by the payment provider itself. There are four entities involved in the merchant client, where the user browse merchandise and make orders. The merchant server that holds the client account, a third-party platform manages the money transactions between different accounts, and the personal payment system's order management platform offers commercial payment functionalities. The addition of this independent platform in the order and payment management process is the unique design in this ecosystem. Compared to the traditional payment systems, the transaction flow in the personal payment systems can be summarized as the right figure. A merchant needs to register two accounts, one personal account at the third-party payment platform, and a merchant commercial account at the management systems. After the buyer places the order, the payment information will be sent to the cash server, while the order information is transmitted to the management platform, while the whole payment and order information will be sent to the cash server in the traditional third-party platform. When the contract payment is made at the cash server and monitored by the management platform, it will send a notification to the merchant server to continue the order process. Next, we talk in details about the transaction flows in personal payment systems. The enrollment process starts with the initial key distribution. A unique key is generated for each merchant account. This key is distributed via the merchant account web page on the personal payment system website. After receiving the order request from the merchant client, the merchant service will generate the order package with the detailed information, and the token is also calculated using the key with some hash functions. The merchant client will receive the order sent from the merchant server and send this order also to the personal management platform. This platform will look up the stored key for the merchant and recalculate the tokens for verifying the integrity of the order package. After that, the payment account information, such as the QR code of the merchant account, is sent to the merchant client. Then the buyer pays the required amount, and the management platform keeps monitoring the money flow. Finally, a notification is sent to the merchant server and merchant account and merchant client for further application behavior. Recall that such independent payment management enables the personal money transfer to realize a commercial account behaviors. However, the separation of order information and monitored payment information leaves the chance for malicious attack. First problem is the Unprotected Key Changing API. This API allows pre-authenticated requests to change the key. In most systems, this API only requires the merchant ID, and this merchant ID is not a secret by design and can be directly obtained by examining the order package. In some personal payment systems, the new key is included directly in the changing replies. Using the new key, the attacker can make arbitrary modifications. Unfortunately, the HTTPS do not protect this attack, since the attacker is the party making the request, instead of launching the man-in-the-middle attack. In other personal payment systems, the new key not directly included in the reply. The attacker can frequently call the key change to disturb the merchant operations to achieve the denial of service attack. The second problem lies in the vulnerable auto generation with two subproblems. First is the local auto generation, which implies that the attacker can tamper with some fields of a locally stored order. Besides, to enable the local order generation, some merchant clients store the key in local storage for convenience. This allows the attacker to easily obtain the merchant key by reverse engineering the merchant client program. With this key, the attacker can actually modify the order package with a lower price. The third problem focuses on the package signature generation. Token is generated by combination all items in the orders with a key into a string and inputting these strings into the MD5 algorithm. Some systems simply combination all fields without any delimiters. As a result, when the surface of one field is shifted to the prefix of the next field, the generated token does not change. For example, we assume the price is 100. In this attack, the attacker modifies the order package by moving the last 0 to the URL. Then the modified package will include a new price of 10 but do not influence the token calculation. The second vulnerability is from the use of weak MD5 hash function. The chosen prefix collision attack allows the attacker to change the prefix part of the input, but still generated the same MD5 output. As shown in this figure, an attacker can modify some of the field in the order package, such as the price, as the two prefix, but still generated the same token. While the generated collision block can be put in some optional fields, such as the URL, without influencing the order JSON package parts. The last problem is the vulnerable payment account delivery. Some systems only display the price, order ID, and the QR code, while the order ID is the only clue a buyer can use to associate the payment with his item. However, a long complicated ID is hard for the user to identify his order. Then the attacker can perform the man-in-the-middle attack to block the order sent from the victim's merchant client, and then substitute the order information with his. Then the victim user will pay for the order, but cannot get his purchased item. As a summary, we focus our analysis on the unique design of personal payment systems. As shown in this figure, there are 4 main stages as previously described, from the key distribution to the notification. We found 6 unique vulnerabilities, and based on these vulnerabilities, we have also created 5 proof of concept attacks. Next, we will discuss our empirical study to analyze the payment services from the personal payment systems. Our goal is twofold. First, we investigate the usage of personal payment systems. The second, we expose their security issues. First, the personal payment systems are currently used in both websites and mobile apps. And the web application is the best recommended method of deployment. So our study shows that these systems with webplex have been downloaded over 20,000 times, according to the statistics from the WordPress and packages. Besides, the data from the personal payment website shows that over 10,000 merchants and 20 million customers have enrolled the personal payment services. Besides, we also found that over 500 apps adopting these systems with over 2 million installations. Here, we summarize the collected 58 personal payment system providers and their vulnerability distributions. To our surprise, we can observe that the security vulnerabilities pervasively looped in this new payment paradigm to cause severe real-world issues. From this figure, you can see that the note with the brown colors is the problem that's fixed after our reported to the provider. Since these vulnerabilities have pervasive real-world impact, we also conduct the case studies to demonstrate that they will cause real-world loss. The first is the string shifting attack. We recharge 30 amounts to our registered account on the PACE API website, but only pay 3 yuan. The second is the key changing attack. We disabling the merchant services on the PACE API website of our own tested account. And also we can stealing the new key on the Xinhu Pay website. The third is the payment substitution attack. We let the victim pay 10 yuan on a resource website for the attacker's order. The last is the MD5 collision attack. We only pay 0.01 donation amount on personal payment system in road block with expected 0.02 yuan. This calculation costed a lot of computation resources and also takes 7 days to find a feasible collision. From our case study, you can see that we carefully design and conduct our case study to avoid impact on real-world entities. During this experiment, we make use of our test account for demonstrating these attacks and always let the authority to know our attack. Besides, we reported all our findings to the personal payment system providers and the 2 supervised platforms in China, the Security Response Center of Tencent and Alibaba Security Response Center. We hope that our effort can help improve the security of mobile payment ecosystems. Thank you. That is all of our paper.